to find you or whatever. I said, you know, if you could almost spell my last name, you can type it into any search engine and you will find how to contact me. It's not that hard. In the social media, I use my first initial and my last name for all of my accounts. But finding my email accounts are relatively straightforward and easy, and anybody with you know, a kindergarten education on the World Wide Web will be able to locate me. And my son said, yeah, I will go down. It's probably still one of the top three hits for his name is when he attended a LUG meeting. It was back when we were in Centerville in the large amphitheater, for anybody who remembers that space. Anybody who went to that space? Anybody? Couple. I can't remember who owned the building. May East run. I'm Steincourt. That's right. That was Ted. I was Ted Russinger, who moved up to Massachusetts and retired.
I remember that space.
So Ted had volunteered that space, and for whatever reason, my son had to come to that meeting. And I was up on the stage, and he was sitting there with me or something, and someone said something about computers, and his comment was, "I don't run stinking Windows." And so there's a quote, "I don't run stinking Windows," by my son on the internet, which is his claim to fame. No matter how much acting he's done or whatever, that's the top hit is his Windows talk. So, like I said, you can find me if you go and give a look. The other thing I'll mention about that space that was kind of interesting, we had two very large talks there. There's a guy who worked at MCI, and at that point, Vint Cerf was at MCI, and so he had Vint Cerf come and talk to us. And Vint gave the talk on how to do IP, basically do an internet connection to Mars. So he was setting up a TCP/IP to Mars and for interstellar travel. And he was talking about the problems that he had with latency. So that was an interesting talk. We had, I think the space held 100, was fire marshal for like 112. We had 150 some people at that meeting. We were sitting in the aisles and the whole 9 yards. It was a good talk. The other one was Red Hat had rented an RV and was doing a tour of the U.S. and I forget what it was called at the time. And we were the first stop. And so they showed up with their RV, and we had about 100 people at the meeting. And after the meeting, we went out to the bus, and the guys from Red Hat were, yeah, this is great. This is going to be a wonderful tour. It's awesome. I don't think they ever got into double digits for the rest of the tour. So at least they had a great start with the LUG and the number of people that we were able to bring out. I was talking to someone this past week, and I was talking about the LUG, and they're like, "LUGs are still things?" And I said, "Absolutely." You know, while today I'm going to guess there are probably somewhere between 35 and 50 people sitting here just as a guest. We average about 20 people plus or minus 10. I'm sorry. -5 plus 10, so somewhere between 15 and 30 people on a monthly basis on a Saturday morning at 10 a.m. So I want to thank all of you for getting up and coming out in the morning. That's the other thing people complain, well, who comes? And I said, we try to move it every 2 to 3 years. People say, let's find a new time. We do a vote online to see when it is, and every time it comes back Saturday morning, 10 a.m. So like I said, I appreciate that. I appreciate Peter's up here. Peter started coming and videotaping and making our things available via live stream.
GPI if you guys don't have HDMI capable stuff. It also has analog video, audio outputs, and it's really, oh, and it also has a series of GPIO pins, which you can't see here, but we will be detailing what can be done with that a little bit later in the presentation. Has a 700 megahertz arm. Generally, most models that you can buy today will have half a gig of RAM. You can get some with a smaller 256 meg. I'm not sure I would buy that. Depending on which model you get, it will have 2 or 4 USB ports. If you are looking to easily plug and play your Raspberry Pi, I can highly recommend that you get the model which has 4 USB ports. USB is your primary expansion option on the Raspberry Pi. Most models have 10 100 meg Ethernet. You can buy ones without them if you are truly space constrained. Why would you want to buy a more limiting Pi? One of the more interesting things that you could do with this is targeting mobile applications. Once you actually need to start worrying about the power consumption of your Raspberry Pi, getting the model which is stripped of features that you are not going to use could be really handy for your battery life. The way that images are done on a Raspberry Pi, it doesn't have your regular hard drive, it doesn't have a SATA port, it doesn't have an IDE port or any of that. It's going to be stored on an SD card, same as your camera. And the newer versions use micro SD cards, so actually same as your phone. The older versions will just use a regular SD card. The easiest way to deal with that when you get a new Pi and you are trying to bootstrap it is to have another computer that you can use to write this card. We'll detail that a little bit later as well. And finally, as I noted, there is a GPIO expansion header on the box. And this is actually detailing which models are available. You've got 5 different models of Raspberry Pi. And these are some of the differentiating features between them. The most popular one is actually probably the B, just because of the amount of units that it is sold. But the B Plus is up and coming and taking over for a lot of that, just because it does offer the 4 USB ports. Okay. So if you go out today and you want to buy a Pi, you are going to need a couple of accessories to effectively use it for anything. First one that I will note is a monitor. Most of the Pi applications, especially if you're just getting started with it, it's really handy to have a local display, see what's going on. So the native output on it is, I don't know if anybody can see this HDMI port. It does have a fallback for some analog video. I really can't recommend it though. I've tried using it. It's not very legible for text. I also noted in here, one of the things, while technically not needed, I really recommend getting just a USB hub for powering your Pi, and then actually using it with the backfeed method if you have a quality hub, so that the same hub that you're using to power the Pi, you can then plug additional peripherals into so that you can use it for more applications.
So you're using the hub to power the Pi as opposed to external power.
Well, there is no, I mean, you can get an external power adapter, but since it is just micro USB, it is easier, I find, to plug the power in on the device port of the hub and then plug the hub back in as an uplink port on the Raspberry Pi itself. So it looks like it's in a little circle, but that's actually right.
It also sort of depends on how many Pis you're trying to power to.
Probably want to speak up so people can hear you.
It also depends on the amount of USB devices you have plugged into the hub. So if you have like multiple Pis, you might not be able to power 2 or 3 Pis from a single hub because of the power requirements of each of the Pis.
That's a good point. If you are trying to do something with like multiple Pis, they're probably each going to need either their own power supply, or you're going to need to have a lot of thought into how you're getting power into the right things, because any power that a Pi is using won't be available for USB devices. So as I noted, the next thing you would want is the USB keyboard and mouse, just to go with your display. This will let you boot up the thing as a simple computer. You need a 4 gig or above micro SD card. If you really want to get into the details of it, you can convince a Pi to use a smaller card, but the easy to use images, so that you're just getting started, really only work with at least a 4 gig card. And again, you need a micro USB cable. This micro USB cable is actually what's going to power the Pi from your USB power source. That's powered into this little connector here. So once you have an SD card, you can either get one that is preloaded with the Raspberry Pi new out-of-box system, I think is the word there. And that will actually then bring you up with a nice little on the display OS chooser. You can choose where you want to go with your Pi from there, or you can just get a blank SD card and reformat it in your computer. If you would like to just reformat it, that raspberrypi.org downloads URL is going to be where you can get the image, and it will give you a bit more details on formatting the card for use in the Pi. So that details the basic hardware setup of the Pi. And once you have one, what can you do with it? Basically anything that you could do with a standard low-end Linux computer should be possible with the Pi. As you've noticed, there's kind of a common thread in a lot of this, and that most of this stuff is using USB. Like I noted earlier, USB really is your primary easy means of expanding stuff on the Pi without getting into necessarily the microelectronics side, which we will cover later. One thing that I've actually got at home now is I had a really old Pentium 3 system of all things that I've replaced with the Raspberry Pi, which just uses a pair of USB Ethernet adapters now to actually do all of the routing that I need in my home network. The advantage that has is that it takes up a lot less power and a lot less space. It's literally this and the 2 Ethernet plugs. Again, you can set up a file server. You can configure it as the OS is a thin client. You've got a full Linux system under the hood. There's nothing saying that you can't go old school on this and set up an XEMCP client. One thing that I don't actually cover a lot of detail on here, but Greg was talking about earlier, I think with the codec key, you can use the Raspberry Pi as a media client. The HDMI port makes it very simple to just plug into your TV, to plug into your entertainment center, and you can boot up into an image in seconds usually that can then stream whatever media you have available to you on the network, even some stuff that is on the internet at large, onto your television.
For anybody who wants to talk, just for a second, RJ, anybody wants to talk details about that at the end of the meeting or after the meeting, I've played with most of the XBMC ripoffs and reburns and whatnot, so I'm happy to talk about that after. I'm going to go find some more chairs. There's a seat up here if anybody wants to talk to.
One here too.
So again, this will basically have anything which is in the OSS, which targets Linux from the open source side, available to you. One thing that this will not be able to do is this is not PC binary compatible. So I can't just take a random application that I don't know anything about from my regular Linux desktop computer and run it on this platform. Stuff will typically need to be recompiled.
What kind of processor is on there?
This is an ARM processor. So it's similar to what's in most cell phones at this point. So, those pins. Let's see if I can get this open. All right. One thing that I did note that the Raspberry Pi has over your traditional Linux computer.
I'm not sure I can.
One thing that I did note that the Raspberry Pi has over your traditional Linux computer is it has general purpose input-output pins. Now, what this is it's kind of a harkening back to the days of, did anybody ever go through the various microelectronics projects that involved interfacing with like a PC parallel port?
Well,
The Centronics interface, you know, the classic
yeah, I think you need something to pinch it with, right?
25-pin header, which was programmable from
I think it's
user
sitting in there,
space.
but that's-
Now, what I'm saying by user space here is that it's not something that I had to write a kernel driver for. I didn't have to get, you know, particularly hardcore in the software side of things to easily interface to some electronics. Just a couple of simple macros, a couple of simple writes, and I can drive these pins on the Raspberry Pi either as triggers, which is the output side of things, being able to trigger other stuff off of it, or as an input. So I can listen for activity on a particular pin, and from that, react with the Raspberry Pi software. This is really what the Raspberry Pi brings to the table as its best feature, I would say. Being able to bridge the gap between the microelectronics and if you break the case, that's fine.
That's only going to be the only way to get it out.
It's extended thing like it's
To bring you an easy interface in between electronics and a modern operating system software stack.
Yeah. Yay!
Whoa!
Ah, sweet.
Hacker!
Thank you. Amazingly did not break it. Okay, so I've actually got in my hand here a Raspberry Pi B Plus, which has the larger of the two images on here. I'm showing you the GPIO pins available on the classic B, or I guess the A and B series, and the A B Plus series. So I'll pass this around, and you guys can see what is available here. So these are actually just, you know, they're not even particularly small pins. It's very simple to get jumper cables and stuff like that to bridge this into your microelectronics board of choice and basically go from there. There are 24 GPIOs in the base.
There's 26 on the
Okay. Okay. So yeah, we've got the 26 IOs here, and then we've got 26 pins, and then a 40 pin connector here. The nice thing is that these two connectors, the first 26 pins are the same between both models. So if you are prototyping a board, you can actually do all of your prototyping on the B, and it will still work with the B Plus. Now, the main gotcha that I would really like to emphasize here is that all the GPIO that is done on the Raspberry Pi is 3.3 volts. It is not the regular 5-volt logic that you will see very often in the world of microcontrollers.
But it's not a 5-volt pin.
It's got 5-volt power, but it does not actually allow you to run the GPIO pins with a 5-volt input.
So it takes 5 volts in.
Right, right. The Raspberry Pi, I mean, remember that this is running off of a USB chain, so it's taking natively 5 volts in. That's what it has available to it. But the processor on the Pi and the GPIO pin setup runs at 3.3 volts.
Where there's an arrow mark.
Are you on the internet to get pages here?
No, that's running on the Pi. It's just that
Oh,
slow.
okay. I was phoning out the network a couple of times, so it's very slow.
No, this actual presentation is running on the Pi, so you can kind of get a feel for how quickly it does simple things like render a PDF. this is the compute board. If you are interested in getting a Raspberry Pi compute board, let me know. Those are pretty cool. Most people today will get the B or B+.
When you finish marking, your face that is
Yeah, other things to note with using the GPIO is that the Raspberry Pi doesn't really lend itself well to doing real-time GPIO applications. So if you need to fire a particular trigger on a GPIO pin or receive something within a very, quick response time window, you can do some stuff with the Linux kernel to allow it to preempt itself, but it's not actually as real-time guaranteed as you would think. And some of the pins on the connector, if you guys went back and looked at the pinouts, have a reserved or a standardized use. So some pins are typically used for I2C, SPI, the serial port on the Raspberry Pi, which again is a 3.3 TTL logic piece, and what they call the HAT EEPROM. That's actually for an expansion board spec that's currently available on GitHub. So if you guys really do like what you can do with the Raspberry Pi and want to start making hardware for other people, like there's actually a standardized board spec layout that you can use.
So what do you mean, what real-time application would you like to use this for?
I like using it a little bit more for the motor control, but I was having issues with it overrunning on the stop, because it would trigger for the switch to stop, but it wouldn't always respond well enough to stop exactly there. It's more of a question of how much precision you're trying to get into the device. For most stuff where you're like, I just need it to respond eventually, it's great. Okay, so this actually brings us into the next section of the talk. Who's doing the I2C stuff? Did you actually want to take a moment to talk about that before I necessarily get into the Gertboard?
Doesn't matter. I mean, I get
stuff. Okay, yeah. So, oh no, that's great.
Some folks use boards, some folks use.
All right, so the other thing that I've got here is I bought an add-on for my Raspberry Pi, which plugs into the top. So this will actually sit on top of the board, and I'll show you guys once the Raspberry Pi comes back up to the front. And this is basically a really simple kind of electronics lab that you can bolt directly on top of the Pi and play with a couple of common components without having to even worry about that much soldering. So this is called the Gertboard. And this brings us a pretty good smattering of just various electronics bits. We've got the I/O buffers, LEDs, push buttons, a collector driver, motor controller, and it actually includes its own little version of the Arduino. Now, one of the limitations of this is that since most of the logic on a Raspberry Pi is designed for 3.3 volt operation, the Gertboard actually is running a modified version of the Atmel AVR stuff, which expects that same 3.3 volt operation. So as long as you're staying within those components, everything actually becomes plug and play.
What's that ATML AVO stand for?
That's the advanced. I don't remember what the V is standing for. Do you remember? Basically it's a RISC type board that you can easily flash your own firmware and stuff in. Part of what this Atmel AVR is already set up to do is you can do things like modify an Arduino sketch and actually get it running on the Pi in conjunction with it. Okay, so like I said, unfortunately, this is one of those things that doesn't lend itself very well to presentation. Like a large part of dealing with microelectronics on the Raspberry Pi is to get hands-on experimentation with a wide variety of components. So this is providing you with an easy way through the GPIO pins to enter that world of microelectronics. You guys have other questions for me at this point? Like I said, this was specifically about dealing with the microelectronics side, so if you want to know other just basic Linux applications for the Pi, we can certainly talk about that.
I guess the cooling is particularly an issue or problem.
Cooling is not a problem. Like, unless you are looking to specifically overclock the processor, there's not even a heatsink on the board. This actually makes itself really handy if you are trying to do things like I noted I replaced my router earlier because I could lock that in the closet and I felt perfectly comfortable just letting it be. I did not have to worry about any additional cooling for the machine. The power consumption is very low. I think it's,
Doesn't matter. I'm
going to say on all boards, it's less than 2 watts power consumption.
It's just there for people to ask
Just also on that point, like they've been able to
Talk really loud. So if you can talk to yourself,
they've been able to in the Arctic use a Raspberry Pi like through the course of a year, trying to do camera related activities. So camera related activities in the Arctic Circle. The other place where they've been able to use an unmodified Pi was in volcanic science exploration stuff. So the extreme environments are actually okay with the Pi. Reasonably unmodified anyway.
So, yeah, where is the Pi at the moment? I can actually show how these two pieces will clip together.
It's confiscated, I guess.
I guess. At least I'm only out 30 bucks.
Check everybody's bags.
Okay.
So basically now with these two boards together, you actually have a mini electronics lab in a box with the Linux kernel available as an interface. So once you've got your program set up to do the basic GPIOs, there's nothing stopping you from saying, okay, now I'd actually like to be able to slap a basic web server on top of this and help to serve out into the Internet of Things. There's even things like a Node.js available specifically for the Raspberry Pi. And then I think we have another talk for I2C, specifically? Okay. Yeah, Arthur? Maybe I can help you. Yeah. So now we're going to have a moment to talk about some of the I2C capabilities on the Pi. This is using the GPIO pins, but it's again for a more specific application. And this will show some of the hardware that you can interface with the Pi.
You guys are going to
Oh, okay. That projector doesn't do GPIO. Right. Oh, okay. All right. I'm going to shut this guy down. Oh, and just in case anybody was wondering, this is the presentation done from a Raspberry Pi, which is running Hydora.
Now, the bit your engine 2. Before you start your engine 2.
How long have you been using Raspberry Pis?
This is your engine 2.
How long have you used them?
Oh, I've been using the Raspberry Pis probably for just a little under a year at this point. Most of my applications, like I really just started getting into more thoroughly using the GPIO pins for something useful. I needed stuff that was replacing like old serial port console servers, and it was cheaper to buy a Raspberry Pi and a grab bag of USB to serial converters than actually buying new console.
How far down does that go?
All right.
So this is going to go down.
HDMI cable, if that's what out.
This is
Yeah. It is.
You might want to move the bag here so I can put it on there.
Yeah, I think it's going to need to be on this table.
This far down to 2. Okay. With your knife. Take a little slit. With your knife.
Okay. All right. Thanks.
Some of you will already have a slit. Like the ambiance already have a slit. Some of you will not.
Let's hope it works.
If you do not have one, make one.
Well, then we'll have live. Try an hour.
Okay? And you will have a hook.
Got it.
Slide the hook.
Yeah, I didn't really catch it. I haven't You're not giving it too crowded.
Move that out. Are you going to keep it on the table here? And I'll just move the camera over here then, and so people can see.
I'll power the Raspberry Pi off.
Using it.
So all I have to do is turn the monitor on.
Eventually, the other thing, using it a lot for
This is
web server stuff is basically.
You can't see the.
So we're getting this set up. Are there any other questions out there? So, yep, Ronnie.
I have a giveaway with up to hacks. It's a few years old, so it's better for somebody who's sort of like beginner level, fun to first come, first serve.
All right, everybody, just go and knock over Roger and grab the book. One of the things I wanted to talk about was the XBMC stuff. So I've done RAS BMC, I've done OpenELEC, and there's a third one that I tried, which I'm forgetting at the moment. All of them work, all of them relatively look the same. What I did learn was streaming HD over Wi-Fi, not feasible. So you will want to use that 10100 port and wire in, and the SD will stream, I'm sorry, the HD will stream and work great. Trying to do it over Wi-Fi, I think I even have a N or whatever, just did not keep up. So
how does Chromecast do that then?
I'm sorry?
How does Chromecast do that? And Chromecast and
I have
TV
no
are all
idea
using
how
Wi-Fi.
I don't know how Chromecast does it. I don't know how Fire TV does it. I don't know how the PS3 does it.
It doesn't really have anything to do with the fact that it's wireless.
Okay.
It's not really the fact that it's wireless, it's that the wireless adapter that you're using, the drivers do too much in software. So it can't decode HD and run the software parts of the crypto for the wireless.
Okay.
That makes a lot more sense.
Okay.
Yeah.
So all I know, like I said, when I wire it in there, it looks beautiful. And it works well. I've had no issues doing it. And every once in a while, I'll rebuild one and run it for a week or two just to make sure that it works. To that end, Peter had asked about compared to Chromecast. I have a Chromecast. I have a Fire TV stick or whatever they call the stick. I just got the Echo, and I'm happy to talk about the Echo later for anybody who's interested on that. And then the Pi. And of all of them, I love the Fire Stick the most. They say it has more memory, whatever. It definitely has more apps. I like that I don't have to use my phone or some other device to start it up like I do with the Chromecast. The other downside of the Chromecast, and someone can tell me I'm an idiot and there's an easier way to do it, is once I start streaming something, figuring out how to pause it has been a pain in the butt if I start it from my phone, because I don't have an option to start from my phone, and if I reconnect, then it starts over from the scratch on my phone, and then it jumps, and I'm sure it's 100% user error. So I'm happy for someone to tell me, because I was one of the people on December 25th that gave Google $5.99 to stream the interview. So I'm one of those people that paid the $13 million. And you know what? It was the best $6 I ever spent, because the whole family sat down and watched it, and it was a lot cheaper than going to the movies, which is usually what we do on Christmas Day. So, and anybody who asks, is it good, is it bad? I would say it is no worse than any other movie I've seen in the theater. And like I said, for $6, it was definitely worth $6. Depending on how young your children are, you may or may not want to watch it. My 15-year-old daughter, I don't think was embarrassed. We did watch Election, which I had not seen in like 10 years. And Election was a lot more embarrassing for her, I think, than just the opening scene in Election, I think, was embarrassing enough for her. So, Rick.
Sophomore humor.
Yes.
Right? When you put it in that context, it was a great movie. Politics all the time. Cable car.
Yes.
The XBMC.
Yes.
Anybody doing anything, any adapters or anything, so you can use that as.
So, cable card. I actually was doing cable card, not on the Raspberry. So I had a Seaton, the Infinity TV. So it's the one I had was a PCIe card. So I put the PCIe card in my server, I get the cable card, I put the FiOS cable card in the box, and I was running that, and then I was using XBMC on the front end. And that worked. Excuse me. I was using it only to stream after I recorded. Okay, and that worked, no problem. That said, on the 27th of December, I cut the cord, and I only have internet into my house anymore. So there's no cable in my house anymore. There's no phone into my house anymore. And it's a little interesting, because I thought Hulu Plus was going to give me everything I need. Because if you have a Chromecast, I think it's till the end of January, you can get 2 months free of Hulu Plus. If you have who has a Chromecast? All right. I don't know if Best Buy is still doing it. Best Buy was doing buy a Chromecast for $35 and get $40 back. So they were giving you $5 to buy a Chromecast. So it was a $20 rebate and $20 Google Play credit. So definitely worth. Like I said, I have wasted more than $40 at name any place in the world that I've ever traveled to. So to have that device was definitely worth it. So the Chromecast, I forgot where I was going with that, as usual. But
getting old a bit.
I am. But yeah, you can get the Chromecast and give it a play. Oh, cutting the cables. So yeah, I thought I was going to be able to stream the TV. Since I watch Archer, new version came out, or new season started on Wednesday or Thursday night. Turns out you need to have an active account with some cable company to be able to stream some of the channels through Hulu. So I haven't figured out how I'm going to address that piece yet. But outside of that, cutting the cord has not been as bad as I thought. Between Amazon Prime, Hulu, and Netflix, I can watch just about anything I want. And I understand there are other ways to see things too. So with that, parents, are you ready to? All right. I just want to make sure I gave you enough time. And so now Terrence is going to talk about what he's doing with the Raspberry Pi.
Is this loud enough to hear in the back? Yes, louder? Okay. The reason why I explored the Pi is because I fiddle a lot with micro. Is this loud enough? Louder? Wow. Okay. The reason why I explore the Raspberry Pi is because I do a lot with microelectronics, and they have what RJ was talking about is these GPIO, or these I/O pins that are commonly found in microelectronics. And you don't find those on a PC or Linux. The Pi is the first thing that I saw that bridges it nicely, cheaply. And as we were just saying, if you blow it up, it's cheap. You can just go get another one. So a couple of months ago, I had at work, I had to have a solution to do some low-level I/O access to a device, and it wasn't working out. And it was a great opportunity for me to use the Pi and justify it at work. So I got a little bit of time at work to spend and learn this thing. So basically, what I'm going to cover here is my step-by-step, what I did going through the Pi, searching the web, how I downloaded the code, set it up, installed it, built it, and connected the components and got everything to work. So I'm going to talk about, here's what I'm going to talk about today. So the nice thing with the Pi is it allows you to talk to various hardware, low-level hardware. The core of this has an ARM chip in it, as he was saying. It's the Broadcom BCM2835. It's their system on a chip. How they make this board for $25 or $29, I don't know, because you buy all the parts by itself, it's got to be close to $100. The common I/O options that are on there that got my attention were these right here. The general purpose I/O, the SPI, which is it's called a serial peripheral interface. If you're into building things and soldering parts, the way to talk to these chips, whether they're temperature sensors, displays, barometric sensors, all this kind of stuff, it's probably going to fall into one of these categories. The SPI has I think it's 4 lines, basically. You have a clock line, you have data in, and you have data out, and then you have an enable. Basically, you tell the chip with the 3.3 volt logic, hey, I want to talk to you, you wiggle some pins, and you write and you read to it. The I2C is a little slower, has fewer pins. It shares the data line. So the data line going into the chips is shared with all the other chips. So you can kind of daisy chain these all together. And how that works is they can all share the same line, but when you broadcast who you want to talk to on that line, they have their own address. So you send a group of bits that represent the address of the device, and then the part wakes up and goes, oh, that's me. And then when the transaction's done, he will then send back on the same line, and all the other devices sharing that same line know to keep quiet and not talk. There's also even yet a slower, it's called a one-wire. It's crazy. I mean, the I2C is the 2-wire, so there's one wire out there too. So you can buy one-wire devices. Actually, they just take power, and there's one line that lets you talk to them back and forth. So I'm just going to talk about the I2C. This is kind of hard to see, but I guess I can post the presentation. There is no real block diagram of the core system on the chip part on the Raspberry Pi. It's made by Broadcom, at least for this. I was able to find this, and these are some of the features that were already discussed. It's basically a 700 megahertz ARM on there, single core, I'm pretty sure. It's got HD video, NTSC PAL, and a bunch of these I/O ports. That's what I'm going to focus on here. This is the block diagram that the community or somebody out there has put together of how to invert it. You go to the data sheet, you can't find out what it is. Broadcom is keeping that to themselves. So you can see there's just a whole bunch of connections, and it makes it a wonderful device for developing microelectronics. And like I said, the reason why I do it is instead of using an Arduino or a microchip PIC, is you have to compile, download it, and then test it. This way, you're on the command line, and you can write code, run Python or whatever, and talk to peripherals instantly. So it really makes speeding up of hobbyists or embedded electronics really easy. So this was kind of shown already. I'm showing a side-by-side between the B and the B+. I bought this one. but then I went down to Micro Center. This is what I was learning. I just heard about the Pi, and I went down. I bought another one, finding out I bought the B+. So the difference has already been discussed. They removed a couple of things off of the sidechain. They added some things to the B+. You have more USB ports. They moved the video inside the analog audio connector, more RAM, and a couple other things. And this is the comparison between the B and the B+ as far as the header. He's already shown that as well. And it shows on there what the GPIO pin is and its voltage levels as well. And this is a zoom in of the B+. And what I brought here today, like I said, I'm talking about specifically I2C interface, which is power, ground, clock, and data. Those two pins, you can talk to a chip by doing what's called bit banging, by toggling the bits yourself and implementing that protocol. You know, send ones and zeros to send the address, and then send ones and zeros to send the data, and then read it back. But what the Broadcom chip has, it lets you use some hardware inside the chip that people have written drivers for, or software for. They just say, hey, I want to do an I2C read and write. And it uses, if you use these pins right here, this is SDA, which is pin number 3 and 5 is SDA and SCL, which is a data clock. That's all you need to talk to these components. So you get some wires, you connect it to the to those pins, connect it to power and ground, plug them into your little module, and then you can start talking to these things. You know, measuring temperature, which is what I've got here as a little demo, and a few other things. So the first thing I did is follow the instructions. I went, like what he was talking about earlier, is I went to the website, downloads, and you can do a live install, to where you just yeah.
This is he's saying that you can get a noob's image that gives you a selection of operating systems to install on the Pi, and then from that it will install one of them and prepare that SD card for you. This is really flexible if you're not entirely sure what you want to do with the Pi, or you've just got the one card and you want to be able to come back later and say, okay, we'll give you all of the options with it again. Once you're comfortable with a particular operating system of the Pi, you can simply get the raw image for that operating system and write that to the card, which will skip a lot of the setup process that you need. Thanks.
So you can find those images on this website on downloads, and they're about 1 to 3 gigabytes or in that vicinity, and they're zipped up, so they're a little bit smaller. You basically download it, unzip it, and it's a binary IMG file. And then if you have Linux, which everybody here does, you use the DD command, which is, I think it's disk dupe, and you just say, well, let me back up. So after going through the process, what he just talked about is, I liked the Debian. For some reason, I wanted to use the Pydora, but I was having graphic issues I've never resolved. When I plugged it into my monitor, I was having C problems, so I used the Debian, which is called Raspbian. So I downloaded that image. That's the image right here. If you find that on the website, I noticed they've uploaded a new one, so there's one that's a couple of weeks old. So you downloaded that zip file, you unzip it, you do a DD, and I use particularly an 8 gigabyte SD card. So what you do to do that is you get the little micro SD. Well, that's the other thing, is the Raspberry B Plus will only take micro SD, the little guys. The Raspberry B takes the larger SD card. And when you go to Micro Center, you can buy the SDs, and they have the regular SD. It's like an adapter. You plug the micro SD into it. The thing is with the B Plus is it only takes the micro SD. So you go to Micro Center, and what I did is I bought one of these. It's a USB, because my PC does not have a micro SD reader, and this will take regular SDs or micro SDs. It's a USB stick, and I plugged it in, plugged the micro SD into this, plugged it in the computer, and I think it was my default setup as a FAT32 system. So I plugged it in, and you'll see, depends on how your system is set up, it may auto mount it and pop up in the display. What you need to do, I found, is you need to unmount that device, and you need to make sure it's the right one. So you can use the dmessage command or whatever means. You got to figure out which device it is that this is, and it'll show up as either a /dev/SDB or SDC. But make sure you unmount it, and then once you're ready, this is the command that I issued on the command line. You got to do it as root. You unmount the device, and you do the DD. The input file is the Raspbian image, and the output file here is the dev/SDC. And then you can specify the block size, and I think the bigger the block size, the faster it is, but it doesn't. You can't just choose a giant one. I use either 1 or 4 meg, but this is what I did with Raspbian, and it worked. Then the next step, so then I've got that. I take out the micro SD, I plug it into the B plus. You got to have your HDMI cable and a monitor that will work, like what we have here. A mouse, keyboard, and that's it. And then you apply power. And we got a power running right now on it. And I have one of these little guys I picked up on eBay. It's a USB device that tells you the voltage and the current. Right now, it's about 4.91 volts coming out of this guy, and it's consuming about a quarter watt, or 270 milliamps. And when it boots up the Pi, you'll see that the number changes, bounces around. As you start plugging things in, you'll see that current go up because USB devices take the power out of the USB port. So mouse, keyboard, and other things. And I think the spec, generally on USB at least 2, is if it's totally compliant, it should be able to supply up to 500 milliamps. But if this guy only limits you to 500 milliamps, then you can't draw 500 milliamps out of each of those. So the total power that this guy can consume is 500 milliamps. So you just got to be aware of that kind of stuff. So right now we're alive. We get the thing booted up. And like I said, this is just what I did. The first thing I want to do is enable the I2C modules. By default, they're not set up. So because this is Debian, you use what's called apt-get, and in Fedora and Red Hat, it's Yum. But the first thing I did is you got to do sudo on everything to be root. You can't do it as a user. I think the default user is Pi, and then the default password I think is Raspberry, but I'm not sure. But you can change that at setup. So you install the I2C tools, and then you enable the I2C module in the software such that when the OS boots next time, the kernel will go and probe to see what's enabled. So what you have to do is edit this file here, the etc modules and the etc mod probe. I don't know. It's basically you uncomment the I2C dev and the I2C BCM 2708. That's in the etc modules, and then this is the blacklist. You comment out I comment out the SPI and the I2C modules right there, so they're not blacklisted. So therefore, when you boot it up next time, it will automatically configure it, and it will be set up and ready to go to talk to I2C. And in this case, SPI. I like to fix IP addresses. I like to make them static because although this guy is by default when you get it and it comes up, if it's plugged into your router, DHCP is running and it will get an address by itself, but it can change. So I like to know what it is because I'm not necessarily always connected to my network, like right now. So what I do is you modify the XC network interfaces. And again, this is going to be different than Fedora. This is all Raspbian. So you modify the XC network interfaces to look like this. And you can just Google this. Just say, I want to do static IP of Raspbian Raspberry. I mean, it's just all about Google, really. And so I fix my address right here to 192.168.1.42. This happens to be actually 3.42, so that anytime I plug it in, I know how to set up my machine and go talk to the thing. So now the IP address is being configured. I reboot, and it comes up, and then that's going to be its IP address. So I don't have to guess or locate it anymore. To log into this thing from a laptop to it, if you don't want to use the keyboard and display, you want to be standalone like I am right now, I SSH into it, and instead of prompting the user a password all the time, you can kind of research this a little bit, but basically you set up the keys. You set up the keys on your laptop, on your Linux, to generate a set of keys. This is the command I use, and then you copy the public key over to the Raspberry's authorized keys file. Basically, it's a long string of hexadecimal numbers, how many characters long it is, but you copy that from this host, in this case, this laptop, over to the Pi, and so then next time you log in, if you just SSH Pi, it doesn't prompt you for password, you're just there. It makes it a lot faster. So that's the next thing I did. I don't like using Python because it seems like anytime I try to use it, there's always dependency problems. So I like working with either directly or in C or C++. So what I've found out there is this thing called wiring Pi, and it's basically the library routines, and you can even find the source code to talk to the Broadcom chip, and it's derived from your Arduino wiring. So I'm not familiar with Arduino, but I know there's a library and probably a bunch of stuff that you guys are familiar with out there, but it's important to this, so if you have any Arduino code, you should be able to write the code and then talk to the person using that. And that's what I did here. So I downloaded the wiring Pi, and that's where it's at. By the way, this guy, I provided a link towards the end. There's somebody out there named Gordon, something that's done a lot, and there's like so much code, so many examples how to talk to these peripherals. It's just really copy, paste, and edit anymore, really. So you download that, and I give you the IP address here. You download it, and then you just build it, and then build will compile it and install the wiring Pi. So now when you develop your code, if you want to talk to the GPIO devices of SPI and I2C, it's already set up. And I keep saying here, what I did originally is when I just downloaded the source code and copied the source code, the .c and the .h files into my own little project directory, and then I wrote, based on examples, some code to talk to the pins. The other thing, so let me just kind of show you what I have here, is connected to my Pi. There's a Raspberry Pi B Plus right here. I've got this nice little LCD 20. This is a 20x4 display module. You can pick them up on Amazon or eBay. It's unbelievable. This is like 12 bucks. Okay. And it has an I2C interface. Normally, they have a parallel way. So you would normally talk to this with about 15 or 16 pins, or about 12 pins. But the community out there has made these little devices that convert I2C to the parallel I/O through a port expander, and that's what that does there. That is specifically for these LCDs, and I thought this is great because I can have a Pi and my little LCD display, and it can just show me stuff, what's going on, the temperature, the time, and I have one more module on here. These are all connected in parallel. So this is the temperature sensor, and this is a real-time clock. Because when you boot up your Raspberry Pi, it doesn't have a battery or a real-time clock on there, so it doesn't know what time it is. It needs to get the time. By default, it'll get it from the network. So they make these little modules, this real-time clock module, which is about $3, and it'll last, they say, 17 years on the battery alone, that you can set the time once, and then you power down your Raspberry Pi, you power it up, and if you can go query and read the time, and then you set your time, so you don't have to worry about what time it is. That's kind of a cool thing, and it's like I said, $3. So this is how I've got the devices connected. I've got the Raspberry Pi Beat Plus right here, and that what I held up is exactly what you see right there. I've got the 3.3 power going over to talk to this temperature sensor, because if you're going to play with these things, one place to get a lot of these modules I'd like is like SparkFun, and they have so many modules. Like I said, temperature sensors, barometric sensors, just all kinds of things. Now it does require a little bit of skill. You got to grab the soldering iron and connect some pins to it. So I've got connected here this temperature sensor, and it's very clearly labeled VCC. It might even say 3.3 volts on it, and it has SDA and SCL, which is the data clock, and ground. So I'm showing that. The LCD display here, it's also clearly marked. It has VCC, SDL, SCL. It's all the same. These 4 pins, it's power, ground, and the clock and data. And then I also have one more here, which is a real-time clock. And as you can see, you can daisy chain up to, I think it's up to 128 various devices. Now the key is they can't have the same address. Now the real-time clock, if you go to, like I said, you go to SparkFun or something, you look at the data sheet, they will tell you what the manufacturer's I2C address is. And it's a number, it's just a number between 0 and 127. And if I buy 2 of these temperature sensors, they're going to have the same address. So you can't plug them in because they're going to collide with each other. So what you got to do, again, go grab your soldering iron, and they give you instructions. Like I said, SparkFun, if you want to do this, it's a great site for this kind of stuff. They give you instructions. You get a soldering iron, and you just either you add a resistor or you remove the resistor, and it will change the address to the next one. Same thing with the LCD. It has 3 resistors that lets you move. So you can have binary that's up to 8 possible unique addresses for the LCD. And they're far enough away, an address space from the temperature, to where you're not going to, they won't collide. And then the real-time clock is yet another. So I connect all these up just like what you see here. You can do it. Well, I recommend do it when the power's not on, then you plug it in, and then you power it up, because you want to make sure that you plug it in the right one. It's easy to, like I've done it, you do it hot, you plug it in, you slip, and then it shorts it out, and it reboots it. So, or you could destroy it. So once they're all connected, you apply power, and you do what I've done here is you apply power, you log into the thing, you go to your directory, and you just run a command, which is I call I2C detect. This I2C detect program comes from your I2C tools. So it's there, it's in your environment. You go there and you run that as root, it'll print out this, that's the command around sudo I2C tools, I2C detect, and the -Y1 tells you which device. I think it has to do with the hardware version. The earlier versions, like B and maybe A, that is a 0. If it doesn't work with 1, that means you have an older version of hardware, and you do it with a 0. And so you issue this command, and then what happens is it goes through and it talks to I2C 0 to 127, and it just queries all these devices, and it just prints it out. And what you can see here is it found, there's 4 numbers here, 27, 48, 68, and 50. Those are the LCD. 27 is the LCD I know because I looked on it on the data sheet. 50 and 68 are the real-time clock, and the real-time clock I found out also has flash memory, so you can actually store stuff on there. With your power device out, you boot back up and go read the data back. And then the 48 is the temperature sensor. I think I've got those right, but you can plug in one at a time, run this command, and see what the address is, and you got it. But yeah, I've got it labeled right here. 27 is the port expander, which is the LCD, temperature sensor, memory, and then the real-time clock. So those 4 devices are what I have running right now. The temperature module is one of those modules. You can do it using, you can also go query it after it's plugged in and recognized by issuing this I2C get command. It's a low-level command that lets you, you can do a man on it. It lets you read and write, but you can't write to the temperature sensor and go read the result back. So what this is as root, you got to be root to talk to the hardware interface. That's why I do sudo on everything. It's the idea I2C get hardware rev 2, which is the Y1, address 48, and register 0. And I didn't print it here, but that reads back. So what you get back is it's going to give you a number, and that number is the temperature.
You can just change the access swipes on the device on your Pi.
What's that?
In your device, where you have the serial port represented here, you can't just change the access swipes. You don't need to sudo.
You probably can. I haven't done that.
What is the drive?
You probably can change it, but it might change at boot up or when the device, because when you plug it in and it does a module, I guess you can probably do something to just change it to full permissions. That's true. You might be able to do that. I haven't done that.
I said it's with that user you are using. Instead of
just give root privileges to the user. That's true. Yeah, that would be.
Oh, vice versa.
Yeah, good. Yeah.
Is it degrees Celsius, degrees Fahrenheit? What's the resolution?
Yeah.
12.5.
This particular device is Celsius, and it's accurate. I think it's 1% or 2%, and there's no decimal. It's just an integer. You get it back. And matter of fact, this thing will print a hex value. So, but if you write your own code and you go do the read, it's just a number. It's just it's a signed byte, I believe. Yeah, or it's a signed integer. I can't remember. And then you can print it however you want. But if you want Fahrenheit, you got to do the math: 9/5 plus 32 or whatever.
Without giving you the decimal point, it's less accurate.
What's that?
Without the decimal point, it's a little less accurate.
Yeah, it's only accurate to it's only accurate to 1 degree C, which is 1.8 degrees Fahrenheit. So yeah, this isn't a precision. There's probably precision sensors out there, but for the thing I needed it for, I just needed to know. Yeah, I needed to know if this device I had was running overheated. So the Raspberry Pi is keeping an eye on the temperature, and if it gets over 60 degrees C, which is really high, then I want to shut the thing down. Okay. So you can't read this probably, but this is the test program in C, and I leave out some of the other details. But what I've got going on here is this is the main. The LCD PCF8574 library you download is a C++ code. So I declare an instance. I just call it M here, and this again with Google and the information, the README, it's all there. But what I'm doing here is declare the instance. I tell it the address. In this case, 27 hex, and then 000 are some other things. I forgot. I just used 000. It has to do with any delayed startup or something. Then for the wiring Pi, so that's using the C++ code to talk to the LCD. I didn't want to write my own machine to talk to that thing. I just want to reuse existing code that someone else wrote. The other items here is the temperature, the real-time clock, and then the memory. I call the wiring Pi function called wiring Pi I2C setup, and you give it the address. In this case, 48, because the previous slide, we did a query, and it showed all those addresses, 48, 50, 68. So now they've all been set. The file descriptor temp is the temperature. The file descriptor RTC is the real-time clock. And the file descriptor mem is the memory. And I pass in some parameters here. I got a string. You can pass in a string. My little piece of test code I'll demonstrate here. And you can pass in a time, how long you want the thing to run. The function called, the first thing you got to do after you've declared an instance is you call m.lcd clear. That calls the method that does all the stuff to clear out the LCD display. Then I'll wait a little bit. I don't know if it's necessary, but I do. And then I put a string. Right now, by default, the string says hello world. And then the m.lcd put s takes the string and then writes it to the LCD display. I go read the temperature using the wiring pi. It's a simple call. Let's see here. It's a wiring pi I2C read, and you give it the file descriptor. That's it, and it returns the value, which in this case is the temperature. I'm also printing it out here. Then what I do is I format the string. I read the temperature. I get the temperature back as an integer. I format the string to say temp. And then the next line I do the m.lcd put string. The parameters there are the row and column. So the first line, row 0, column 0, it's going to say hello world. So that's going to be the top line. Here, line number 2, not one of those, 0, 1, 2, 3. So line 2, it's going to have the temperature and then write it. And then I got some other code up here, which is, that's all it does. Is it waits 1 second, it reads the temperature, does some other stuff, and just writes it to the display. And so now this thing is completely standalone. You power the thing up, you can put this in your startup file, and it will go read temperature, and you can carry this thing around. Don't have to have it connected to a computer or anything, and you can do what you need to do. It's really, really, really cool. So, and if you want, the nice thing is all the code has now been developed, and I know it works talking to these devices. I can then go move it over to an Arduino or a micro or another embedded controller, or I can just leave it with the Pi since they're so cheap. So I am going. Okay. Yeah. Before I do the demo, the real-time clock. The real-time clock. I found out it too is already supported. This one I picked up, I think, off eBay, and it was like I think it was like $3. It turns out this particular one is supported by the Raspberry Pi. I think the module installer. I forgot earlier, but it's the in order to enable the real-time clock for this guy to use it in the native Linux commands, you have to do this. You echo the DS1307, and you tell it the address, and you echo it to this location. It's a file, and by doing this, you're telling Linux, I think the kernel, say, hey, you have a new device out there, and it registers it, so you can issue the HW clock commands. In Linux, you can set your time, as some of you probably have. You can force the time of the clock, and you can read the hardware clock. You can just read your system time, and you can read the hardware time. So at this point, when it powers up, my Raspberry Pi probably has something that's 1970 or I don't know what date it is. Once you set the date of your Raspberry Pi, you can then take that date and then write it to the real-time clock. And you do that with the HW clock command --sys to HC. So what that does is it sets the real-time clock with the Raspberry Pi. So that's it. So you can power the thing down, power it up, and the real-time clock continues because it's running out of battery. People were asking, why don't they have the real-time clock on the Raspberry Pi. Well, to keep costs down, although it's only $3 for that, maybe size too, they decided not to have it on there. So again, but it's available as a peripheral if you want to use it. The next command is to view the current date and time stored in the real-time clock. To do the date and time on your Raspberry Pi, you just type date. But if you want to say, well, what's the date of the real-time clock, you do HW clock minus R. Say hardware clock minus R and reads it. And then if you want to, another command is to set this limit system time. What's that?
It's the same as your system.
No, this sets the. This will say.
The opposite.
That's HT.
This is the opposite. Okay.
Yeah, this one sets the pi. This one reads it. This one takes takes the real-time clock module and sets your Linux time. And you can do it by hand, but you got delays. You may not get the exact time. So this command is supported. It's really cool. I just kind of stumbled across that. Or you can set it manually with this command. HW clock minus my set minus date, and you just specify it in this format, and it sets the real-time clock for that. And then if you want to unmount it, but you want to get rid of the device, what I found is I wrote a program that I wanted to read the real-time clock on my C, and it wasn't working. It's because this had controlled it. So to put it to unmount it or remove it, you do the echo 68, and you direct it to the delete, and it'll unmount it, and it won't see the hardware clock anymore. So to add the clock, you do this line. To remove the real-time clock, you do that line. Okay, so now I'm just going to do a little demo. Let's see here. Can you read that? A little bigger? Okay.
Doing it up there. Okay.
So I just have a little script here that it calls my program that I built. You saw the example code, compiled it, and I'm saying run this for 5 seconds, and then pass it a string that says show temperature. You can pass it whatever string you want. This particular program. I'm going to run it a little bit longer. Okay, so I'm going to say LCD, run for 50 seconds, and send a string 1, 2, 3. And what I'm doing in there is pretty much what you saw in the code. I print the string, I go read the temperature or read the real-time clock. It's not enabled right now because I did not issue this command earlier, so it shows up as just a peripheral, and I just print it out. So you probably can't see this right now, but it's now updating. The third line has the temperature, and if I touch the temperature sensor, you'll see the temperature move around.
I guess someone didn't convert to Fahrenheit, huh?
No, it's Celsius. There, it's bouncing around 25, 24.
Yeah.
So you probably can't see that back there, but it's running for 50 seconds. Yeah. And then at the bottom, I have RTC. What I'm doing is there's like about 8 or 10 registers in the real-time clock. I haven't explored what exactly they are, but they're like year, hour, month, seconds.
Bye-bye.
Oh, yeah. And I'm just reading the first couple of registers. I'm reading like the first 4 registers and just printing them out. It looks like one is ticking every second. And that's probably the seconds. And I have up here the date, which is January 7th, 2015. So that's probably the last time I powered this thing up. And I think the Raspberry Pi stores that when you shut down and you power up, it just picks up where it last left off. So what I would want to do is issue that hardware command to go read the real-time clock. And I'm not sure if I said it or if it's what state it's in. And then it would then update the Raspberry Pi.
So from a technical perspective, you're doing a pull. Is there you're not using interrupts, you're not using any of the features that standard PCs are using.
Correct.
Is that something that is available? Because if you keep pulling all your devices, that gets slower and slower all the time.
Correct. So his question was, am I pulling everything? Because that becomes very wasteful. So in the piece of code that I've got here, depends how sophisticated you are, but you can actually do it as a thread. What I do is I go read everything, right into the display, then I go to sleep. And I go to sleep for, I don't know, half a second or so, or maybe 1 second. And then after that wakes up, again, I go back and reread it. So if you do that as a thread, it will free up resources, and it's not really taking the CPU time that much. I recently found out that there is support for interrupts on the thing. So I thought that was pretty cool. I'm going to be fiddling and exploring with that, because when you're coming from the embedded world, you want to be able to do stuff in real time if you're really cool, as opposed to just polling. So in this case, it'd be great. Have an interrupt, fire off your piece of code, and then just exits or goes to sleep. So that's going to be the next thing I'm going to fiddle with. I saw it there, and I give you a website that has all the stuff. It's great. Let's see here.
It would be an interrupt whenever it changes, right?
Well, I'm not sure. I'm guessing that there's a pin on the GPIO that's dedicated to an interrupt. And a lot of times how these interrupts work, you can say, interrupt me when you have a change of state. So if it's a 1, or if it's held up to 3 volts, and then you transition to 0 volts, that'll cause an interrupt, and then you can go do your code. Or it might be the other way around. So it's mostly, I'm guessing it's an external interrupt. There may be software interrupts. I don't know. I haven't explored that. So this is for the I2C. I do have a few examples in here of some GPIO stuff. I was hoping to slap together a small demo, but this is pretty much the I2C piece. I do have a few more slides that I address a good GPIO example of where you basically do the same thing. You hook up some wires and so forth. So if there's any questions on I2C, just go ahead and jump in right now.
Square. To me, it's I2C, but
yeah, I2C or I2C is what they call it. It's really IIC, but they just call it I2C or I2C, and it's IIC, which is integrated circuit. And so that's where it comes from. So let me go. Let's see here. How do I do it?
Presentation.
There we go. Okay, so this is kind of real recent stuff I've been playing with. I found out in those. I think it's the wiring pi. There's, like I said, a whole bunch of stuff. Turns out there's some low-level GPIO. There's some GPIO commands that are supported. Here's one that I saw. It's just called GPIO read all. And what it does is it just goes and it reads all 40 pins on the B+, and it prints out their state and how they're configured.
Make sure the bag stays inside, fold it over.
So oops.
It's going to be soft. It's going to be soft. Get it saturated with glue.
Okay.
You're going to take it, stick it inside.
So think of this as the connector. Pin 1, 2, 3, 4, 5, all 40 pins right here.
When you're done, your rocket's
It tells you what pin it is. It tells you there's a pin number, and then the GPIO library and Raspberry Pi, they use a different pin numbering designation, and that's pretty much what that is. So if you want to talk to GPIO 0,
you need one sheet because you're
It's actually pin 11. So that's why it's important. It doesn't mean it's pin 0. There's no pin 0. If you see GPIO 3, it doesn't mean it's pin 3. You have to look it up on the diagram that I had earlier, what the mapping is. So this is kind of a cool little thing. It just tells you what the state of your GPIO is. And a little demo, a little test that I did at home because I wanted to know, hey, I want to just blink some lights. I connected the pins shown here. I wanted 5 volts and ground because you need that to power whatever it is you've got. I'm also using 5. I found the next 5 GPIO lines that I just connected the little wire to. I brought it out to a breadboard and hooked it up to a LED. Now here's something, I think it came up last time about how much current can we supply with GPIO pins. So when they designed the Pi, they assumed that any given pin can support up to 16 milliamps or a total power of 50 milliamps. So that doesn't mean you can use all GPIO pins because it will exceed the 50 milliamps. So you take, if you're going to use all 50, take 50, all 17 pins, take 50 divided by 17, and it means you have about, it's about 3 milliamps of current if you're using all. So this is the circuit. I don't know if you can read the schematics, but basically how I hooked up the Pi, I grabbed some wires, connected it to, I have a tricolor LED, which is red, green, blue. And then I connected the 3 pins here. And so I have power going over to the LEDs here. And GPIO pins are used to, if you write 0, it will make the GPIO power ground. And that will complete the circuit. So therefore 3 volts goes through the LED. And that's limited. You limit the current here. I use 1,000 ohm resistors. And then you can blink the LEDs. Here's where I'm using the GPIO pins itself to power. So I'm using GPIO 0 and 1 connected to the resistors, to the LEDs, and then back to ground. So.
Then what a question.
Yeah?
Well, just a simple one. This is something I've always wondered, which is, does it make a difference between if the LED comes before the resistor or after the resistor?
So the question is, does it matter the order of the resistor and LED, which comes before which? In this case, no, it does not. Because the resistor just limits the amount of current. What happens, the LED, it might be rated for, let's say, 30 milliamps. But if you give it a 5 volt supply, the LED has the voltage drop of just about 1.5 volts. If you connect it to a power supply, it's going to basically just, however much current you can give it, and it will just cook it. It'll just, it'll just pop, it'll flash it. So you got to limit that. You got to do a little bit Ohm's law. You take the, in this case, 3 volts. You subtract the 1.5. It gives you about 1.5 volts. So 1.5 volts, if you want to limit it to 3 milliamps, you just take whatever P equals IR, and I just used 1 kilo ohm because just easy math. It ends up being 1.5 milliamps. It doesn't take much to light up the LEDs. So 1.5 volts across 1,000 ohms is 1.5 milliamps. So to blink the LED, I wanted to hurry up and test this thing. I wrote a little bash script. In order to turn the thing on and make it GPIO, if you want to blink something or control something, you issue what's called GPIO mode 0 out. That's saying you're defining the mode of that pin. It could be an input, it could be an output, it could be, I don't know, I think there's some other definition. You can define it as a pulse width modulated, you can, all this stuff. So what I want to do is blink the LED. So I say I want to make GPIO 0, which is pin 11, I think in this case, to an output. And I set up my little loop here. And then I'll have a little counter going. And then I issue the command GPIO write. GPIO 0, write it to a 1. I go to sleep for 100 milliseconds, and I rise to 0. So it's just going 1, 0, 1, 0, 1, 0. It blinks 5 times in 1 second until the loop is done, and it just works. It's so simple. This is the back screen. And the thing is, well, I like doing stuff in C because that's probably about as fast as you're going to get it. Bash is slowed down because it's interpreted. Python, I never have luck with it. And C program, this is what it takes to do the same thing. A couple includes here. Whole wiring pipe. And then there's some defines here, defining which LED to blink. And then I do it. It's called wait a half a second and write low. I mean, that's all you got to do. And then you can get creative. Whatever you're writing your own code to do that. Visiting a lot. That guy right there, I think, wrote Wiring Pi for the Raspberry Pi, and it's just a great site, very informative. If you want to do this kind of stuff, he walks you through it. Plus, there's forums and discussions and people talking about it. This really accelerated, me learning about this thing. And I think that's it. So, if you want to explore talking to peripherals, no longer does it take microcontrollers and a lot of soldering irons and stuff. You can do it if you're familiar with Linux. And the Raspberry Pi bridges that gap, brings it to a low-level component thing, and really, I can see this in so many areas. I think that's what's happening is it's exploding, not only in the universities, but like I said, I'm using one even at work for something. One thing, I was talking to some other guys who have used this. They've noticed they have some Raspberry Pis they're using around the world, and they have noticed the thermal issue. That when it's in a really hot environment outside, they've noticed that it gets flaky. So I guess, I don't know what the spec is on it and so forth, but again, on eBay, I found some guys making little heat sinks. They're little stick-ons, this little copper right there. And just like $1 and get like 3 or 4 of them. And so I haven't had a problem. The Broadcom chip on there is the one that's doing all the work, the heavy loading. It's got the ARM and all the I/O, so it's the one that gets warm. Other than that, I'm very happy about it. One thing I found, and maybe somebody here has some insight here, is if it's running and I just pull the power, that's not a good shutdown. And it works most of the time. But one time, I did that, and I must have been in the middle of writing because I corrupted it. And when I plugged it in, it would not boot. So, I was stuck. So I needed to go create another image, reboot, and so in order to shut the thing down, I highly recommend that you issue the shutdown command, shutdown -H now. But if you're going to build a portable thing that's separate from the PC, a laptop, you don't have the luxury of doing that. So maybe you want to have a GPIO thing that pulls every once in a while that looks at a pin. I'm guessing here, right? And then you press that pin, and then your GPIO reads that, and then it issues the shutdown command. But my goal for this, I have a project that I would like to build something for my mom. She's older. She doesn't use a computer anymore or anything. Email. I want to send her pictures. So I'm thinking, how do I give her pictures long range without her doing any work and not mailing them? So I'm thinking, if I have a Flickr account or a link to that web page, maybe she can use that because she's like, more elder she gets, the less she want to read messages on the phone. So I got to make it really, really simple. So that's my goal over there. figure out how to solve. So, if there's any questions, again, I'm just learning this, the Raspberry Pi. I love it. It's a great bridge. If anybody has any questions, you want to see the demo up here, come take a look at it. But it's a really cool, fun little device.
Yeah. I like the devices sort of. What are you looking for in the real world?
What I'm using it for at work is we have a little unit that we transmit a known pattern, a known waveform at a certain frequency. And we give it to a guy in the field who wants to go out to the range and transmit a signal, an RF signal. But they don't want to carry a laptop around or anything like that. So we build a box in there that has a transmitter, it has an amplifier, and it has a Raspberry Pi. The Raspberry Pi gives a display to him such that when he turns it on, he says, oh, okay. And I went one more step because I used a USB keypad, plugged it into there, and I'm pulling the keypad and monitoring, and he can actually select which file he wants to transmit, and he hits enter, and then the Raspberry Pi controls it, sends the data file to the transmitter, and it just transmits it. Now, the thing gets hot because it's a transmitter, and it's like a 10-watt transmitter, and it's confined, and it can get warm. So I want to monitor that temperature of the transmit amplifier. If you transmit too long, you got to keep the thing cool. So that's why I wanted the temperature sensor in there. The user interface is the LCD. It's really simple. You don't have to lug around the laptop to plug it in. And then also the real-time clock is something like, well, I'd like to have the right time and date on the thing. So it's really a great solution. It's now a portable standalone box. We can go out there really cheap. It's under $100 for all this stuff. The other component's more expensive, but and it's just a standalone transmitter. So it can be used in many other things. So any other questions? Yeah? No, what I plan to do is going to the etc/rc.local file, and if you want anything to be done after your Raspberry Pi is all booted up, like blink lights or anything, you just stick it in that file. And what I would do in there, and I plan on doing, is doing the hardware clock command and basically go read the real-time clock, because I'm assuming it's going to be plugged in. Go read that with the HW clock minus R code minus
HW dash S.
Yeah, the dash, yes. The S sets it, so it's another command. Basically, read the real-time clock and set the Raspberry Pi. That's what I plan on doing. But right now, it's not. It worked. It worked. So I just got to do it. So that's what I plan to do.
Any other questions? All right. That's thank you again. I thank RJ and Karen for their a couple of things. So I know I've mentioned this multiple times, and hopefully everybody has added it to their feeds, is Lifehacker as a website that has a lot of interesting stuff. So they actually had 2 Raspberry Pi things. I know one was definitely Lifehacker. I think both were. One was buying a screen, like a screen for your phone and whatnot that you could plug into your Raspberry Pi, and doing live traffic. So what they had was they had a Raspberry Pi with this display hooked up to it that was getting a live traffic feed so that you could look and track yourself, and they actually had it hooked up to their phone. So the phone was wherever in the car, but you were using the data stream on the phone to display in your car to be able to have basically a GPS system. So it's kind of nice, kind of easy. The device, they pointed to, I went to eBay, and I think it was about $52 for the display. It's actually a touch screen from what I gathered, and you could do, of course, other stuff because of that. The other one was taking an old VCR. It was actually a 1981 Mark M VCR and making a portable media player. So for anybody old enough and whoever owned a boombox, that was my car radio that I would carry around when it wasn't up on my shoulder like LL Cool J. But it was basically making this device. And what they did was they put a screen on it so you can have a nice interface. Where you'd eject the tape was a powered USB 4-port hub. It was actually running on batteries and the whole 9 yards. So it actually had how to wire it, so all the pins or all the buttons on the VCR actually were working to interface with the device. So it's a very cool little read, and the guy said, you know, if you can find one of these devices, if not, being able to hack whatever VCR you have was probably possible with a little bit. And it went from life hackers, I am 80% sure it went to Indestructibles, where all the things are. But again, it was a nice little hack to take your Raspberry Pi and to do something more interesting. The two things, I don't know if the Girl Scout cookie seller is still here or not, but someone said if you're interested in buying Girl Scout cookies, or maybe someone here selling them. So there's the name right there. And I will say it's actually going to be really hard, I think, for the poor Girl Scouts this year, because they're actually taking online orders this year. But they offer 3 new flavors, crazy flavors, I heard also. So, but Jason will be happy to take your Girl Scout cookie order. The other thing I heard is there's a maker fair that's going to be coming. I'm going to get the information and share it with the log. Brian's going to send me the specifics, or Jason may know the specifics. Well, he'll go get, oh, wait. Nova Mini Maker Fair. Sign up as a member. Maker Fair. Nova.com. Sign up to volunteer. Sign up penguins.com/go. Crazy straight. But it's on the board there, so you can look at the board on the way out. You see. Okay. And I'll put it up on the log for those who are interested on doing it. What I want to do, what Brian asked was, would we be interested in doing a display or something? And I'm going to look at the date and the information, and I'll probably sign us up to be a member, a sponsor, a displayer, what have you, so we can do stuff. And what I figure is we can bring some pies, we can bring some other stuff to help. Maybe people will have old USB keys lying around that are only a gig or 2 gig that they're not using anymore. Maybe we'll figure out how to put something on that we can give people they can take home and boot up and use. So we'll figure out something that we can do to replace, since Fossey is dead and no one goes to Fossey anymore. We'll do something with Maker Faire that's a little bit easier for us to get to. Depending on what we end up doing, we may try to find a corporate sponsor who can buy a bunch of those USB keys, or I'll see if maybe we can get them in bulk and take up a donation and be able to do that. There is no speaker yet for February, so if you're interested in the topic or interested in talking, drop me a note. And we'll get it set up. I think that is it. You have something, Jason, you wanted to?
If anybody has not seen the massive changes to the space.
So we haven't noticed at all.
Sorry. If you have not seen all the massive changes to the space and you would like a tour, I can give anybody that's interested a tour today. If you've heard me talking excitedly about the fact that we're getting a 4.5-ton CNC mill, it's here if you want to see it.
Whoa.
It's massive.
Are you giving fork ride lifts?
Yeah.
That depends on how much you're going to drive.
Okay.
I'm going to be bribed into a fork ride.
Whoa.
Any other questions out there? Yeah.
There's for people who are interested in the pie stuff, there's supposed to be a raspberry jam happening at Hack DC at the end of February. I think February 28th. I'll put something out on the mailing list, but I don't know how organized that is going to be, but it's being talked about on the Hack PC mailing list.
There's also a guy here who I didn't even bother to get his name, who's looking for people to interview about free software, if you're interested in talking about free software. And I told him he should talk to you.
Free software sucks. Hi, I'm Adam. I'm interviewing people for a social movements class right now. If anybody has anything to say about the free software movement or the open source software movement, I'm going to be interviewing people for the next week. If you could leave me your email address and your name if you're interested, I would love to find a way to interview you. I'm trying to introduce Linux to a younger generation of people. I feel like it's something that a lot of people have forgotten about. I'll be over here with the sign-up sheet if anybody's interested.
All right, excellent. Any other questions, comments, announcements, anything else? I see there's a drone out there that they're going to go outside and play with, I'm guessing, Jerry. So if anybody wants to go outside and play with them.
No, just me killing my new toy.
Okay. Let's see. I guess that is it. I want to appreciate. Oh, is anybody hiring? Any
Red Hat
companies out there? Red Hat's hiring. vPrint. All right, so send it to, if you have are you on NoVALUG, Nova or MA Jobs? Okay.
Two guys, let's actually get this for real recruiters.
Scale, Red Hat's always hiring for those who are interested. Scale, actually has 3 or 4 openings now. They're actually looking for someone to manage their IT infrastructure. So it's an internal IT. We need a support person, and we need a consultant go on site and break stuff. If you have any enterprise storage, so if you're an EMC NetApp type person, or whatnot, we'd be able to talk to you. And you, the Girl Scout?
My daughter's actually back there in the class, and I couldn't pull her in, but she's selling Girl Scouts wheat cookies.
Wait, okay.
I said that. I got nervous. But we will special deliver them to the Linux meeting next month if you are interested in supporting it. So I'll back and grab her.
All right, great. So we have competing people selling Girl Scout cookies. And so we're going to videotape the fight to see who gets the orders. But so anybody who's not here, so she lost. Oh, okay.
Thin Mints, Samoas, fight!
So no, we couldn't find you at the time. Yeah, and I couldn't find you. So with that, we'll go ahead and disband. I want to thank everybody. This has been our largest meeting in a while. We had about 45 people at the height of the meeting. So thank you. I'm going to work with Jason. I think overall, in the back, you can more or less hear. I'm going to work on a way to make it a little bit easier for people to hear next time. And what we'll do is, I will work on getting here a little bit earlier. Had a meeting beforehand to try to set it up for audio to make it easier for everybody.
We are going to have a real